Okay, session is going to be recorded. Those who didn't have time to join and are registered, or those who will see this presentation later, welcome everybody. Nice to have you. We are going to talk about how to reduce costs and save our planet, and share some insights about our implementation of Rancher Dedicated as a service on EKS, AWS managed Kubernetes service, the Elastic Kubernetes service with Terraform, and provide some insights about other tools. Let's switch to the presentation. Yeah, my name is Arash. Together with Alexander Giza, we are going to provide a session. Some weeks ago, we had a great session together with Francesco Giolazzi from Italian. He works by last minute, provided a very great session about their implementation of autoscaling of Kubernetes on AWS with and without Spot instances. It's highly recommended to have a look on this session. It's I can't add so much to what Francesco presented. I learned a lot. I hope you will too. Perhaps before we start, we did tweet on the internet 3 days or 4 days ago, asking people about how many Kubernetes clusters are they running, about over 50% idle in their organization. So as you can see, perhaps you might want to go to our Kubernauts Twitter account and vote about it during the session if you have time. As you can see, many organizations, over the half of the organization are running Kubernetes clusters, which are more than 50% idle. So that hurts not only your budgets, but also our plans. And this session is, as I mentioned, we are going to share some findings and within a real world project or one or more projects where we was involved this year. Now we started to have a look on all the clusters which we are managing. They are more than 40 Kubernetes clusters. Most of them are running on OpenShift or on AWS with KaaS, Kubernetes operations. And we started to move some of our implementation to EKS and see how we can, which tools we shall use with Terraform, EKSCTL. They are nice, great tools, Pulumi and Ranch as well. And yeah, and we found for ourselves, perhaps in your case, it will be different to go with Terraform, and why I will explain it later. And we will go through the code of the upstream Terraform EKS module, which changes was needed to be done to have autoscaling of Spot instances. That's auto fleet spotting, the scaling of Spot instances with autoscaling, to reduce your costs for sure, and how we are going to use additional technologies like container native storage, cloud native storage, or container attached storage with OpenEBS on the environment. And then we will have a demo and show you how you can get free access to Rancher Shared as a Service offering, which was launched a few days ago. And hopefully you can save our planet through implementing auto-scaling of Spot instances or whatever on-demand instances as well. There are some other ways to reduce your costs and save your money and our planet. We will have a look on K3S Bonsai implementation for local development, and as well introduce some ways to deploy Kubernetes with K3S or catch up on Raspberry Pis for development. And perhaps if you want to use that in, there are some implementations of our Raspberry Pis in data centers where you can have Kubernetes, mini Kubernetes clusters for many use cases with edge computing and so on. So, and then yeah, most of the time we will have a demo. It's a recorded demo and some live demo about auto-scaling of Spot instances, mixed groups, and then Alex, I will hand over to Alex. Alex will show you our Prometheus operator implementation on EKS, what was needed because EKS had some limitations, because it's a managed service, we don't have access to etcd, and we had to adapt the Prometheus implementation for getting custom metrics and scale via custom metrics. That will be the session after the demo. So perhaps some words about the comparison which we did by the beginning of this year. We are using as Pulumi as well, right? So EKSCTL, not yet, but perhaps later. We decided for ourselves and all for our shared implementation of Ranch shared as a service to go with Terraform. As well, we did some implementation with Terraform Rancher provider. So we can use the Rancher server to talk with Rancher and deploy clusters, RKE clusters, EKS clusters, whatever. All of these implementation are on our GitHub, Kubernauts GitHub account or my own account. And I will show you that later. So the main differences between these solutions was the skills needed, the first one. So for our team, we didn't have so much skills to deal with Pulumi, for instance. Yeah, so some guys from other companies who are working with Pulumi, we have the code, it's very nice, they are using that. But for our use case, we decided to go with Terraform because it is more extensible. It's a huge number of Terraform modules which we can use to extend Kubernetes and our infrastructure, and especially on AWS. The Terraform provider for AWS is really great. It's one of the most used providers for implementing infrastructure as code. And it supports different operating systems, the Terraform EKS module. Currently, we are using the Amazon Linux for our development, but it is also possible to use Ubuntu. And it has somehow support for managing node groups, but not yet meant for managed node support. And okay, what is lacking somehow is the lack of GitOps. GitOps is better implemented through EKSCTL. No wonder, because it comes from Weave network. The guys who implemented EKSCTL and open source that, and Amazon has announced that EKSCTL is the default tool to deploy EKS. But well, we had some problems with that, so it is still in alpha. And as mentioned, the main reason why we decided to go with Terraform was we had the skills in our team to extend the Terraform modules and implement new modules for auto-scaling with custom metrics and so on. Good, well, so let's talk about scaling. What's scaling? Most probably all of you know. Let me please let people in. They are in the queue. Okay, hope it all. And scaling is, as you know, the ability to increase or decrease the compute capacity, right? So not only for applications, but also for other use cases. So for services, let's see, you have a queue service, or you are using some other services which is integrated with your applications, right? So, and the scaling happens if an event happens. Yeah, so we can scale up on events. They could be, for instance, if the number of requests per second goes up, that's a custom metric. You can scale your application, and for that, you can use auto-scaling groups in AWS to scale automatically your workloads on your machines. So here is a nice link provided at the bottom on the on Amazon website. What we are going to show you is a real-world project where we used Terraform with to deploy EKS in several node groups or pools of nodes, the worker nodes for pre-caching in our case, or also on-demand instances. In this implementation, which we are going to show you, we are running 100% spot instances, not on-demand instances. In some cases, perhaps only one on-demand instance for monitoring, so that our metrics which come from Prometheus doesn't get lost. So, but even that is possible to use with spot instances. About the architecture, the microservices architecture of the application, which we are using. We went live yesterday with that. And yeah, that's an application which pulls terabytes of data from database and provides an API to query the data to a front end. It's an internet-based application. We cache the whole data in Redis and provide it on EFS, the Elastic File System of AWS. Currently, at this time, we are going to move the whole thing in the near future to the Redis will be moved into the EKS cluster, and we are going to use OpenEBS as cloud native storage with container attached storage technology to have more performance and at the same time to reduce our costs. So we are very happy with that. We had this first implementations, and we are working with Metadata as well to get this implementation as a reference implementation for other projects as well. So how was the cost saving? That's the real, yesterday, that's the latest report which we got from our client on AWS. By the beginning of the year, we had a cost of over 40,000 euro per month in January. And at that time, we used spot instances as well, right? So But by moving the whole implementation with autoscaling of spot instances, we was able to reduce the cost, I think, up to 80% in May currently. So, but we will reduce that further because we had to run clusters in parallel. That's the report for a single account. We have more than 20 accounts where different clusters are running. So you can perhaps imagine, we guess we can save more than $500,000 or more, more than €1 million for our projects which are running on Kubernetes. So yeah, that's the same. You see how the cost is going down day by day. And for sure, we will cut our costs more and more and gain more agility, right? But that's the main thing which we want to have near cost saving. With OpenEBS, here's a very nice white paper from Data. So if you have interest to have a look on it, please feel free to do. I have to admit, let people in, they are too late. Okay, welcome me, Oleg, Felix, and all. Hope you come in. Yeah, and I will show you later to a demo how easy it is to implement OpenEBS. OpenEBS is a Kubernetes implementation of cloud native storage. It means storage is made in containers running in your clusters. They are near to your workloads. You don't have any latency, and at the same time, you can save costs and gain more agility. We will show you that later. Okay, and why Rancher? So we are using the EKS cluster. All of our EKS clusters are managed with different Rancher servers. Some of them are running on single instances with Docker, which I don't recommend. But we are using that widely. Most of our Rancher servers are running on a single instance. So we had a meetup some days ago, some weeks ago or months ago, and talked about which Kubernetes. Here is the link to it. But the results, it was from this meetup, why not to go with Class API, which is, by the way, the implementation from VMware, so for Tanzu. And VMware announced Tanzu some days ago that is generally available. For sure, a very nice solution. I didn't have a chance to look a deeper look. It's a several software as a service as well. It's different to Rancher and OpenShift somehow, and but the Class API is very nice. We did some POCs, so proof of concept. If we shall go with Class API for our Rancher as a service, or for the Kubernetes clusters, which are going to be managed by Rancher. And as well with OpenShift or Rancher together with RKE. RKE is a tool where you can spin up very easily a Rancher Kubernetes engine and then deploy Rancher on top. One of the main reasons why we decided to go with Rancher was there was a lot of reasons. First, we can use K3S, the lightweight Kubernetes implementation of Rancher. And then we have currently not so much experience with the container runtime environments CRI-O, which is used by OpenShift. You can't use any Docker anymore with OpenShift. And but the way for the future is, I think, Ranger will provide containerd runtime environment as well. And one of the big points was why Ranger, because we can have the integrated sys benchmarks, which comes through the Ranger interface. I will show you in a few minutes. Okay, then let's come to the demo. How the EKS deployment with auto fleet spotting can be done. I recorded a session, a screencast about how to deploy. It's really very easy. You can find the source on GitHub. I will show you that, or in this presentation, the slide link is on the meetup side. And perhaps before I show you this screencast, let us go through the code. So Terraform, the Terraform EKS implementation is like any other thing by HashiCorp. Open source. The module is on GitHub. So, and what we did here, we created a very simple, somehow simple base module. A module is in Terraform, a folder, right? So, and wrote some bash scripts to copy this base module to a new folder or module, and then change some variables and parameters so that we can deploy clusters very quickly in any region in the world. Because the project where we was involved in, they want the same implementation to work in US East 1 or US East 2 or Canada or whatever, because they are going to use this implementation worldwide. So each module has a main Terraform script, so it's really easy to understand. We have our Terraform provider for AWS and some modules like a VPC module for EKS, the EKS module itself. And the most important thing is here we can use different pools. So what is a pool? That's a worker node group, right? So, and in this pool, we can define different sections. So Spot 1 is a worker group, which is labeled here with kubelet argument, extra arguments. And with that, we can decide which kind of workloads are going to land on which type of instances, of mixed instances. So mixed instance means you can have different type of EC2 instances, right? So up to 7 for in this case, or 5 or 6 in this case. I think this instance group has 7 instances, and that's really important because Spot instances, as you might know, they come and go, right? It might be for smaller instances, Amazon will take all the instances in a region where you are, and you will run out of those instances which you have. For instance, if you are going to use a C5X large instance, it might be risky, right? So, but we are using that. We are in our real world project, it is possible to use a single instance, and such instances, yeah, so they might survive. I don't recommend to go with a single instance. And you can define other worker groups. So for our caching, for instance, so we are using a spot pre-caching and then label that with a non-node selector pre-caching so that some pods which are they will tolerate that, and then they will run only on those instances which are labeled with that label. And okay, for a monitoring instance, we have a single group. This group was commented out by the deployment, which I will show you. And let's go, we'll come back to here. There are some other useful informations and the installed script itself, how it works. But let's go for 2 minutes to a demo, which is recorded here. So this is the same folder which I showed you. It has this script to deploy EKS cluster. If after running that, you will be asked about the cluster name, and yeah, and you have to decide in which region you want to deploy that, because for some regions, mainly for US East 1, it is different to create a S3 bucket where our Terraform states will reside. So I will show you that in the code in few minutes. So it will go on and checks with Terraform. We are using make in the background. So make runs Terraform plan, Terraform init, and Terraform apply with a custom variables file, which has, I think, our credentials and so on. Yeah, that's a cluster TF. No, it doesn't have, sorry, it doesn't have any credentials. You don't need to expose your credentials in your files. And after the plan is successful, it is going to add 46 resources, mainly create a VPC, Visual Private Cloud network for you, and then add security groups and, right? So it's boring. So we can show you live if you want after this session, but we will upload the video also to our video channel. But I would recommend, if you are interested, take the code, run it yourself, and see how you can spin up only spot instances and work with EKS. So it will run and run and run and run, right? That's boring. And at the end, it will print out your subnets, and then create the kubeconfig, right? So, and with that, it's ready, right? So I will show you that in a few seconds on my in the terminal. So that's the base cluster implementation. So there is no auto-scaling, nothing. So, but the auto-scaling groups will be added. They will have some additional policies which is needed for auto-scaling and IAM. So the IAM nodes, they need certain permissions to scale spot instances, and this step is done through the code. So you don't need to do that anymore. That's the cluster auto. That's the important thing which was added. And it's really very easy. You define as a policy, IAM policy for the worker auto-scaling groups, and this will get added to your worker nodes. And what is important for you, if you are going to work in teams, then you have to provide okay, that's the template of the backend, S3 backend, to store your Terraform state, so you don't need to keep it manually. It's for security and so on. And as well, if you are using that in other implementations by customers, many admins are working at the same time on different clusters, then you will need some locking mechanism by DynamoDB. So by creating DynamoDB, and the module will, or Terraform will take care about locking. And what else was needed is to create some resources for the Autoscaler. And the only thing which the module changed, or the script which we run, is that it adapts the, that's from the base module. I will show you the base module will be cloned, as I will show you in short, to a new folder, which is a module, and it will create a file with the certain autoscaling group, which was created for the worker group. So the worker group, which I showed you in the main file, will have an autoscaling group named with the demo meetup autoscaling, and then spot and a random number here. So, and now we are going to apply this and create the autoscaler. Good. So that's a live demo. Dangerous. If it doesn't work, please forgive me. But I did some info here, what we need to apply. Okay, let's show you what we have. Okay, get nodes. We have only one node, hopefully, yeah. And get all -a. We will see that's all after EKS installation. That's the base components or containers pods which you have in an EKS cluster. Yeah, so you don't have the control plane, you don't have any etcd, and you don't need to worry about it. That's the great thing about EKS or other managed services like GKE on Google. So now we want to deploy the Autoscaler. So this can be found on the Amazon website and GitHub, I think. So, but not in the base module. It's not included. So we'll create the Autoscaler, and if we say -v, then we will see, in all groups, get -a-v. Okay, it's already running. Yeah, the cluster Autoscaler, no, that's a single pod which is running. And now we can get, sorry, we can see cleanup and then cluster Autoscaler and get the locks, hopefully. Okay, it doesn't like it, then let's go and say cat pause -a and and cube system, and then this one. So if there is some problem, -f, then you will see that here. But in general, it should, it will give you some information about how idle or not idle your nodes are, and the state of scaling. So now that we have a single instance, right? We will deploy Nginx deployment and scale it out. So it will, the first command will install only Nginx in the default namespace, I think. Yeah, it is running. And now if I go on and scale that, because we want to show you how autoscaling works. We have only one node, and if I say, okay, get pause dash v, you will see a lot of nodes, pods are in the pending state, most of them, because we are using very small instances for this demo. And now I guess the autoscaling group and the cluster autoscaler will talk to the API. And if we go to the MR, we don't need to go to the Amazon dashboard. I guess if I call get nodes dash v, then we have still only one node. It might take, that's something we are scaling via CPU and memory, right? So that's not so fast. So therefore, in the real world projects, you have to scale with custom metrics. And one of the best ones is the request per second. So let's go on to the dashboard. It's there. So an hour ago, I scaled up, scaled down some of the requests that they are the spot requests. As you can see here, was closed. I scaled down back, but I hope if you see these instances are coming up. So if we change to the instances, then they are already here. Okay, that RDaaS are two instances that the demo cluster, which we currently using, they are initializing. So if I go here and then call that, hopefully, we will see these three instances have been added. So if we do that to scale down again or scale in again from 10 to 1. And in a few minutes, this scale down needs more time to scale up. Yeah, so it is not so fast, and it's good so, because in the real world, you have to implement as well some mechanisms to implement the autoscaler in that way that your pods, the nodes which are going to get killed or get back from the spot pool, you will get informed 2 minutes ahead. So, and the pods which are running on those spots which are going to be killed, they have time to move to other nodes. So for that, there is also a ready to use implementation YAML file. If I find it here, or is it in the add-ons? Okay. So that's mainly how the autoscaling works with the cluster autoscaler. That's the only thing which you need to add to the Terraform module, with some more settings and labels and so on, which is provided on GitHub. But it is nice to know for you why Terraform. And so again, Terraform is really the only solution which I know. It has so many modules which we can use out of the box for providing add-ons. So one of the nice things which we had to use for every environment is EFS, right? The Elastic File System for different environments. Well, our code is here not really dry. Yeah? Dry is don't repeat yourself. For every environment, for our dev and prod and other environments, we are using different EFS modules. But for instance, for JMeter, for load testing our application to see how scaling works up and down, we are using JMeter. And what you need is also the Nginx ingress controller. We have a Terraform module, which is using EKSCTL to deploy. If we deploy, copy that to the main folder, the Nginx ingress controller will be deployed automatically. And as well, the Prometheus operator implementation, you can spin up a cluster in a new region with a single command with all of these tools in less than 20 minutes, right? This is something for disaster recovery. So if a region comes down, in our case, the customer asks, we want to have the same, exactly the same cluster in a new region. So what we did as well is running Rancher on top of EKS, which is not supported from Rancher. So but we are using that. So our own Rancher shared as a service environment, which you can use as well, is free, is running on EKS. And we have also other Terraform Rancher server VMs implementation, which I don't recommend to use, but we use that for the customers because it's cheaper. So perhaps what I wanted to show you, how the installation script works, which I showed you in the video. So it will check if you have Terraform in your PaaS, AWS CLI in your PaaS. You need an AWS IAM authenticator for sure. If you work with AWS, you know that very well. That's optional if you want to use kubectl to run or deploy some manifests from within Terraform. There is a nice module here or plugin for Terraform. So it means during you provision your cluster at the same time as we did at the last step was, I think is here, I hope it's here. Okay, now that's in the make file. So yeah, it will ask about the cluster name and region. That's all what you need to provide. And then it goes on and then substitutes with set some variables in the file, so, and deploys the cluster. Yeah, that's all. Only in some, it will ask about the region, and if the region is EU West, then it will create another bucket with another settings that for EU West, I think, and the other way. And the other things is for all other regions to create a bucket, the S3 bucket. So, and it as well, it creates a key name, yeah, or key to access the Spot instances over SSH. And so the SSH port is closed, the 22, through security groups. You have to open it manually or with Terraform code. You can do that as well to allow port 22 to be open to SSH into it. And then, yeah, it will list your clusters as I showed you in the video, and then deploy, yeah. And then deploy at the end the metric server. The metric server is a must. You need the metric server for scaling. And then after the metric server is ready, it will show the status and will open. It will open. That's some sort of marketing. This page, and you can get started with providing your, for instance, my name and my email address. And if I click here, that's only for B2B customers. You can try that, but you don't get any free cluster for that. But no, I'm joking. In the near future, we will provide a shared cluster for you too to get access to RDaaS. So I hope it works because I have already an account. Okay, thank you. Then I have to switch to my email client, which is secret. So, but I can show you the email. I received this email, yeah, just now. And then I have to click on this login that's pre-filled, but the password is okay, the password is empty because I have an account for sure. I'm not sure what is going wrong here, Alex. So the password might be your username. I think I didn't deleted my account in Rancher because I'm using that option.
Yeah, Arash, you already
I know what
deleting the account in Rancher.
Okay, but you will be able to log in. So, and after you are logged in, you won't see any clusters at the first step. If you need access to a cluster, the easiest one is to create a cluster locally and import that into this environment. But for now, I want to show you how easy is it if you go and create an EKS cluster with Spot instances in Rancher, how you can import an existing cluster. Yeah, so our cluster name was somehow demo meeting auto spotting. Let's provide the same one. Click on create, and then you will get a link. I have to export. I have already exported my kubeconfig here, and then apply. And Rancher installs the Rancher agent and cluster agents and role binding and whatever for RBAC and so on, the node agent in a new namespace. So get, let's clean up here a little bit. Get NS, that's the namespaces, then this new namespace which Rancher created. Get all -n cattle system. They are running, creating. Okay, it takes a little bit. Let's try it again. That's terminating but I guess it will restart. Let's try that again. Okay, now it's fine. So if you see something like this, then you go back to the Rancher interface. You will see our demo meetup autoscaling cluster is imported. And we have this autoscale, yeah. We have these Spot instances. You will see some of them are labeled. They are for deletion. It's a little bit small, and you will have, that's nice because we scaled down from 10 to 1. And now Rancher or the user which is using Rancher, they will see the nodes are going, they are scaled in back. And in this case, 3 of the nodes are, you will see that as well in Spot requests. State I have to refresh. They should be closed now. I'm wondering why they are not shown. And okay, Rancher is better than EKS. They will close later, but here, if I go to the instances, then you will see, these 2.1 was terminated. We are still using 1.2 instances for the demo meetup autoscaling spot. And these are, yeah, that's very interesting. So this environment, which I showed you, that's RDaaS, where you can get access to it as well for sure, is running itself on this EKS management spot. Yeah. So it means Rancher is running only on 2 spot instances. That's the nice thing. Even you can run it only on 1 spot instance. So it costs you, I think, around $30 or euro per month, 1 instance, a small instance or less, I think. And okay, if you are going to use EKS, then you have to pay 70 euro per month, right? So this means for such a cluster with Rancher running on top, you will pay 100 euro. So good. Then perhaps some words about storage. So we have different kind of storage classes. The default one is on EKS. We are using EBS and EFS in other environment. We didn't install the EFS provisioner here on that environment, but it's included in the code, and we will provide that the EFS automation together with OpenEBS implementation for EKS with CStore and MyStore very soon on GitHub as well, hopefully by the end of next week. Tomorrow we have a session to deploy MyStore. That's a new storage engine for Kubernetes with OpenEBS. And let's go back, please, to, I think I'm ready soon, hopefully, if you're not tired. And where I stopped was here, and perhaps some words to, it's not only marketing, but if you want to implement your own implementation similar to what we did, is really easy. There are some differences. The shared as a service is free forever. Their dedicated service is on some explanations about it is here. So that's for free forever. You can use with a single user. If you want to have a managed AWS account, we will provide that to you with Rancher and so on, and you will pay whatever, near to 1,000 euro per cluster per month. And this is only for those who have already or want to get Rancher Enterprise subscription from Rancher. Then we will provide consulting together with Rancher. Yeah, this is where we are. To be honest, we are earning our money, and so that's here. What we hope we can get in the near future, more customers who want to get cloudless. Yeah, that's our marketing. To say customers, they don't need to manage their own cluster. Developers or small agencies, they need only Rancher. Go in, they have a cluster, they can deploy their application, launch from the catalog. By the way, we did an integration with Bitnami that helped free catalog here and so on. So is very easy to do if you want to do that on your own as well. And the clusters which you will get very soon, if you have even the RSaaS, the shared free offering, you will get a ephemeral cluster. Ephemeral cluster means we will clean up the cluster nightly. So we will delete all namespaces or the entire cluster, but you will get access to it forever. And you have also, that's a mini cluster, right? So And important to know that that's more to get to know Rancher. Yeah? So to work with Rancher, and it's not intended to be an alternative to the hosted Rancher solutions. The lovely guys and our friends at Rancher, they have for enterprise customers a new offering that's they have announced the hosted Rancher with Rancher 2.4. And it's something for large enterprises or some mid-sized enterprises who want to start it with range. I think it's less than 10,000 euro, about 9,000 euro in per year, I think. This is highly recommended if you want to go with that. But our SaaS is more for playing to import your cluster, deploy a new cluster, and then delete it. And so, if you're serious to use Rancher, even you have to deploy that on your own, or you don't to deal with the infrastructure and the cloud, and we will recommend to go with the dedicated. You will get your AWS or perhaps soon and on Azure account, and then we will manage that for you on the cloud or even on-prem if you have OpenStack, VMware, whatever. Okay. Then, yeah, that was what I'm saying. It comes with a managed AWS account and it's only for B2P customers. The enterprise version is only for those who are willing to pay for Range Enterprise subscription, and new offering for Azure will come soon, or in Q4 perhaps, we hope, if you have time. So one thing, everybody can run his own Kubernetes as a service, and so and use Rancher on top, or learn to love Rancher, I say. If you're on the cloud, please use a managed service like EKS. If you don't have any reason not using a managed service like GKE, EKS, AKS, Azure Kubernetes service. So that is what is as well recommended by Rancher. So Rancher Kubernetes engine as itself, it makes sense if you are on-prem. So if you are on-prem, and as most of our customers are, yeah, so they are using Rancher Kubernetes engine, most of them on vSphere, VMware. And so, their Rancher is very strong in on-prem environment. So, and is the easiest and most stable near to OpenShift for sure, and affordable solution for on-prem. And if you want to use that on-prem, the right way is to have first a management cluster. So you need somehow a Kubernetes cluster where you can run Rancher on top. So the first step is to use the RKE tool, say RKE app. You will get a cluster, and then you can go with Helm and deploy Rancher on top. And that's your Rancher management server running on the management cluster. And from there, you can either use their Terraform provider or Rancher itself to deploy additional, they say, downstream clusters. Yeah, so the worker clusters. Please don't install anything on the management cluster, any running workloads for your applications, perhaps only your central monitoring. Yeah. Which we are doing. We use the management cluster to host our Elk stack, to host our Prometheus, or host our whatever. And so our management tool, Jenkins, and so on. And the downstream clusters, they are managed by, if we are here, perhaps back to here, this cluster is the management cluster, EKS management Spot is our cluster. The Rancher is running on top, and these two are downstream clusters. For instance, this is a bare metal cluster, right? So very powerful and idle. Yeah, don't hurt and save our planet, right? So if you are on-prem, sometimes you have to run idle. That's something for our development, right? Most of our, if you see here, our nodes, no, the cluster itself, or the cluster is running idle, and so don't do that. Okay, for in our case, sometimes they are not idle. Yeah, we are using 90% of the resources on the cluster, which were in some cases I deploy Kafka or whatever, and the cluster other colleagues of mine too. And then this cluster was set up a few weeks ago with the latest Kubernetes 1.17.4 through RKE, right? So we deployed this cluster through the management cluster, through this cluster. So perhaps here, if you want to deploy, I showed you, again, a cluster. You go to the global level, add cluster. Either you can use existing nodes or import that. If you or you can use, and let's say from here to deploy EKS, which I don't recommend, right? So please don't do that. If you are serious to run EKS, go with Terraform, EKSCTL, or whatever, and use auto-scaling and auto-spotting and so to reduce your costs and save our planet. Again and again, I have to mention. So, and save your money for sure. So I'm going to come to the end. Perhaps if you are interested to try the RDaaS and would like to have a cluster very quickly, real usable cluster, you can use K3D, whatever. Here is the repo. By the way, yeah, I think I provided the link somehow, somewhere on the slides to for you to try. We'll extend this repo with the cluster autoscaler. And then there are some other repos here, which you might want to have a look on it. That's our bonsai to deploy K3S on your local machine very easily. And this is a single command, and then import the cluster from through this range interface and play with that to know range and how it works, and then you can delete your cluster. In some cases, some guys told me they have access here. They went at the cluster on EKS and then deleted the cluster, but the cluster was not deleted. Please don't do that. Rancher has no control over cluster which they deploy in the cloud. It is deployed, but if you delete the cluster, if I go here, let's do that. So to show you that what it means. If I go here and then say that was our demo meetup auto spotting cluster delete, it doesn't mean that Ranger deletes this cluster on it. This does not allow it. It has not the permissions to delete the cluster. And so the cluster is not deleted. If I go here and perhaps get called, I will see that the resources not found in Ranger because Ranger deleted this cluster, these components in the cattle system namespace, which was running. After I delete that, Ranger will clean up that, and it's very nice. Yeah. In some cases, might be that it doesn't delete and something gets stuck in terminating state. Then you have to edit the namespace and delete the finalizer and so on. And so you know that. Okay, that was about how to create and the autoscaler. So with that, perhaps some words to, or here, did I forget something? No. With that, here is the link to the repo as I showed you. You can get access to our training site. That's this link for the practical Kubernetes training. We provided practical Kubernetes training, so with range or implementation on EKS or local on OpenStack and so on, or bare metal if you want to attend to that training. That's more on-site. We don't provide the implementation training off-site or online, unfortunately, for now. But the practical Kubernetes training, you can find that here, and how to register. That's on the training practical. So the next training will be in July 2nd and 3rd. The registration link is here. It's somehow affordable, right? So if you'd like to attend, but I'm sure you are Kubernetes experts and don't need that. Good. And now I will hand over to our lovely Alex.
Yeah, Arash, yes.
Questions in the, I see there are some questions.
Yes, you almost answered all questions. There are only one question regarding the cost reduction from Dimitro. On a slide with a detailed cost reduce, you've huge increase in elastic costs. Does it mean that redesign of the app also was able to reduce costs? Is the question. He mentioned the second, the sixth slide, I think.
Okay, let me please read on a slide with detailed costs reduce you huge increase in elastic cache costs. Does it mean that redesign of the app also was able? Yeah, sure. So we did, perhaps going back to here. So what we did, and I missed, sorry for that to mention, so we redesigned our app as well, right? So you will see that in here in this the structure. So that, or in this diagram, not directly. So what we did is, in the previous architecture, we didn't use, for instance, caching. So we add caching, intelligent caching with Redis to play with EFS. And the second generation will bring Redis into the cluster, not outside the cluster, because Elastic Cache, here we have been using Elastic Cache, right? So here we are using another Redis implementation, and with OpenEBS to reduce the cost. But this diagram, which you will see, and perhaps here is better to show you. Here, the yellow one is Elasticsearch service. Yeah, that was one of the huge costs which we had with running Elasticsearch as a managed service outside of the cluster. So what we did in the first phase, we implemented Elasticsearch through a central logging and monitoring with Kibana and so on. And in the second phase, in the next phase, we are thinking about to run Elastic Cache with container native storage or container attached storage on our own. So we don't have higher managed services. Okay, with the managed services costs to be eliminating that, to be honest, you have operation costs. Yeah, so you have to see where you want to pay less and do more, or do less and pay more. And so that's really what you have to decide. And the other question was about, share the recording for sure. Any other questions? I hope, Dimitro, I could answer your question if I got it right. No, yes, okay, good. Then thanks for your attention, and I will, if there is no question, perhaps you can, if you have any question at the end of the session, welcome to write in the chat or unmute yourself even to ask questions. Thank you, and Alex, I will stop my share and hand over to you.
Yes, but you got my subject a little bit off topic.
Okay, so the reason why we included your topic was again about autoscaling with custom metrics, but the main thing is how to implement metrics or with Prometheus with operator the right way, and this is what you are going to show, and for sure to have external monitoring for services with the Blackbox exporter, because if you run Kubernetes as a service for your organization, you will have a lot of external services and external endpoints which you have to monitor. And yeah, the Blackbox exporter is not really well documented. And this is, enjoy the session with Alex. Okay, Alex, please.
Yeah, this, I want to show you a little side project of mine. As Arash mentioned, the goal was to monitor our RPE endpoints of some of our customers with a reusable and portable Kubernetes deployment. Therefore we choose the KaaS Prometheus operator with the Blackbox exporter from Prometheus as a stack, and we choose the operator over the pod or deployment because of the self-healing and auto-apply Prometheus targets properties. And the Blackbox exporter is great for probing HTTP, HTTPS, DNS, TCP, or ICMP endpoints. First, we want to go to have a look at the operator deployment, and after that, the Blackbox deployment. Starting with the KaaS Prometheus operator. It's an open source project from KaaS, which can be found on GitHub. The easiest way to get a running instance is via the Helm chart, which they provide. You have it's V2 Helm chart, so you have to install Tiller first. This is a small shell script here, which I can show, which you can see here, which creates the service account, make the role binding, gets Helm if it's doesn't installed, and in its the Tiller deployment on your running Kubernetes cluster. This is part of the official Helm 2 documentation. So it's almost copy and paste. After that, you are able to deploy your Prometheus operator via the Helm chart. I suggest to use two parameters, the name and the version, to make sure that every deployment of your Kubernetes, of your Prometheus operator has the same version. If you want to duplicate the deployment in several regions, for example. The default Helm chart comes with some resources, some default resources, the operator itself. The default resources will be installed in the default namespace if you if you not define another namespace. It begins with the Prometheus operator, a Prometheus instance, the white shapes the alert manager, the kube state metric server, and the Grafana instance. And the green shapes will be configured and deployed in the next steps. So this is a manual part. First, we deploy the config of the alert manager to get a great alert message. After that, we install the modules of the probes. I show you later. The exporter, the Blackbox exporter application will deployed next. After that, it will be published via a service, and the almost last step is the Blackbox exporter service monitor or your custom application service monitor. And after that, we will define a Prometheus expression, which will be fired if the service goes down or something. Yeah, the Blackbox exporter. So first we define an alert channel and message. It's a known example of the documentation of the Blackbox exporter. So it starts with some liveness probes and some initial values. After that, the message and channel will be named. And the interesting part is the Slack configuration. So you can use many channels. The normal alerting channels, mail, Slack, or something which is provided by Prometheus. In this case, we use the Slack, so we added a Slack hook. After that, we choose the channel where the message will be published. And after that, we this is a almost copy and paste example from the Prometheus website. So it's a standard alerting message. And in the bottom, there's another short shell script which deploys the configuration as a secret in the cluster, so that the operator can add this configuration to the alert manager automatically. After that, we for separation, you can also run the Blackbox exporter in the same namespace as the Blackbox exporter, but if you install many Blackbox exporter, it gets a little bit messy. So for separation, I decided to create an example namespace, and after that, I published the Blackbox config probes in the example namespace. This is the first interesting part, which is not documented in the official Prometheus operator documentation or in the Blackbox exporter documentation. This injects the modules, the custom modules, into the Blackbox exporter configuration. It's documented when you publish the Blackbox exporter without Kubernetes. But it's not so easy to publish this when you use Kubernetes to add the configuration if you use Kubernetes. So this is a little hack. I debugged the application to find the right file name for the configuration and the path. So there you define the checks. These are two probes that the first checks the endpoint which will be mounted to HTTP 200 posts. And the second one will be 401 HTTP request checks. So this, if you want to add more probes, ICMP or something, you can take a look at the docs. With this little hack, you will be able to easily add custom probes to your Blackbox exporter. When you add your needed probes, you can deploy the config map in the same namespace as the Blackbox exporter. And if it's available, you can create the Blackbox exporter itself. This is a very easy part. So I have marked the changes, the important changes. So you have to mount the config, and the application will be started automatically with these parameters. After that, on the right-hand side, you can see I have created a little service to export the Blackbox exporter application. Then we create the custom resource monitor, which consumes the which pushes configuration in the Blackbox exporter too, but it consumes also the results from the checks of the Blackbox exporter. So I have added some comments to, this is the first important part are the labels. You have to make sure that you use these two labels that the Prometheus operator can find the service monitor. So the release has to be the name of your operator Helm deployment, and the Prometheus is, I think, a constant parameter. After that, you can go to the specs. The namespace selector limits the scope of the Blackbox exporter. I think the best way is to limit the Blackbox exporter to one namespace. After that, you define the selector, which is necessary to find the Blackbox exporter service. And then you define the endpoints. The first endpoint is monitors the Blackbox exporter itself, because there's no parameters passed to the endpoint configuration. And the second, I started the endpoint configuration with the scraping interval. You can use the parameter or something else, do what you want. But here the second endpoint becomes the HTTP 2 module, 2XX module, and our Kubernauts.IO website as a target, and the path probe. and the port HTTP matrix. HTTP matrix is defined in the service, which is also 9115. And this probe, this endpoint probes or checks every 20 seconds the liveness of our website. After the target port, I do some relabelings. I have added a screenshot on the left-hand side. The relabelings is necessary to group the results later in the Prometheus expression. So because you can only use labels in Prometheus expressions, in case if you want to do some probes against a specific API domain, you can pass the label from the target parameter, which you can see in the screenshot at the target label, well, at the endpoint under the target label. You can pass these label with label to labels as an instance. For example, you can choose the label it's free of you, so that you can easily do the Prometheus expressions later. The third example on the top of the right hand side is a liveness probe of a custom API. It has an authentication, but I have, to make the probe easier, I just check if it's available and rejects my request. The probe, the matrix, the target port is always the same, and the relabelings, when you find some relabeling configuration for your own, it's almost every time the same. This is a custom resource monitor, and after that we tie all things together in the Prometheus rule. It's custom resource 2. It's provided by the Prometheus operator. Here are also the labels important, so that Prometheus that the operator can consume or can find the Prometheus rule. Prometheus rules are always in the same namespace as the operator. And the specs are very, very simple. So you can you start with a name, and the magic is the expression. So this is a very simple expression. The probe success, I named this the probe success expression, is here fired every 3 minutes, and every 10 seconds. It's default value by Prometheus, and if it's 0 for 3 minutes, the operator will be sent, or the alert manager will be sent a message, an alert with a message target instance is down, and some additional information which we defined earlier. And I added the severity label critical, so that everyone knows that's a huge problem. That's it. So I'm sorry I don't have a hands-on session. So I think there's one question. I've had some problems with the Blackbox exporter, for example, when our website is running HTTP 2, only TCP HTTP 1. So do you have the same experience? No, not until now. Sorry.
We are not using HTTP 2 for now.
Yeah.
Yeah, thanks, Christian. That's the nice answer. You can use them in parallel. Okay, thanks, Alex. Very nice. Awesome. So the importance of your presentation, I think, again, is you really need a sound matrix implementation for your props and so on with Prometheus. And the only way, or the standard way, is to use Prometheus with the operator. So you will find also the operator implementation is on, for sure, on GitHub. But this implementation is going to be provided on our Kubernauts GitHub account. Is not committed yet, Alex, right?
No, I will do it in the next few days.
Yeah, tomorrow. Tomorrow we will provide that, and I will provide the full implementation of, because some guys was asking if it's open source. Sure. We will provide the install script for you as well, and some more guidelines and the add-ons. So some add-ons is really very helpful. Terraform. So and also for OpenEBS, you can get that for sure on the OpenEBS side. But for EKS, we are going to provide a custom implementation with Maestro, NVMe, and so on. And the other thing is, if you want to run range with Terraform, there we have also a module for that, several modules, different versions with Terraform provider, without Terraform provider, and so on. And then we'll provide that on Kubernauts GitHub. Currently, the implementation, the link which I pasted here is I'm on my private public GitHub account, but you will get that through Kubernauts GitHub account soon. And I pasted, if you have any question, I pasted a link to our Slack, and you'll get the self-invite site on for our Slack channel. You are welcome to come in and ask any questions. And let's see if there is other questions here. From Tom, it's another question. Blackbox exporter is really nice. You are using it to check HTTP uptime, SSL certificate expiry, external system uptime, an application endpoint, all with Alert Manager and Grafana dashboard. Yeah, thanks very much, Tom, for the great feedback. Suma Singh is asking, what's the benefit of using the operator? I am implementing the Jenkins as an operator, but struggling to convert pipeline to DSL. Okay. In general, operator provides some kind of self-healing, or it has built-in intelligence to run your application. For sure, if there is some problems, and we have with some operators, to be honest as well, then you don't need to use the operator. Yeah. So if you are fine without the Jenkins operator, whatever, then go with that solution. By the way, we have also we are working on for CI/CD on Tekton, which I highly recommend to use that, or if you can use GitHub Actions, then it is really nice. We are, for ourselves, in our projects, we are going to move away from Jenkins. Tom asks, can you scale the Prometheus operator when having multiple clusters? If you mean if you can use the Prometheus operator for central, as a central service, yes, we can, and we are doing that. We have a central monitoring and logging server where the Prometheus operator is running, and that's the right way. So if you have different operators on different clusters and you want to maintain all of them separately, then you will have a lot of headache. Hope that was the right answer. Okay, thanks. Thanks, Christian. It was nice to have you. Hope to meet you soon in person after Corona. Perhaps at Innovex by the next meetup, hopefully. We are in the same city. Okay, guys, thank you very much for attending at this time in the evening or even in the night in India or in the morning in the US. Thanks, everyone. Hope to see you in person someday, perhaps by KubeCon, by the next KubeCon. Let's see when it happens. And thanks, Alex, for a nice presentation. And keep safe, take care, and see you. Have a nice day, evening, morning, whatever. Thank you. Bye-bye.
Thanks. Stay healthy.
Thank you.